Hello, listeners and viewers. Welcome to another episode of the finance section of the Impact Co podcasts. And like last time, another episode that's slightly different than us just talking about companies. I want to talk about artificial intelligence. Now, I know what you're thinking. Nish, I have heard about artificial intelligence everywhere, from social media to YouTube to podcasts. I might even use some form of artificial intelligence in my day-to-day work, day-to-day life, from ChatGPT to Bard on Google to something else. I want to sort of have a discussion that should be slightly different from using AI in our daily lives, because I want to discuss more the investment case for AI. That's what this podcast is about, how we think about finance and investing concepts. And I think AI is an interesting one. There's a whole new arena of investments related to AI, thanks to the developments in AI. More than that, it gives us a nice example, a nice opportunity to delve into a topic. I always say to students, as well as to some of my peers, younger peers in the industry, as an investment professional, you get to learn a lot about different industries at the same time. And that's very different from most careers. If you're a dentist or a civil engineer or an accountant, you have a focus, you have a specific space where you're an expert and you get better and better in that space. Whereas in investing, we're supposed to understand multiple industries at the same time. We're supposed to develop our skill in understanding these industries. We're never going to be like the experts within an industry, but we're supposed to get good, we're supposed to get better. So I've actually spent a number of months now just delving into artificial intelligence, what the use case is, how we got to where we are. And I want to share some of that with you in this episode. It's going to be a two-part series. In this first one, I want to talk about the sort of background research that led me to this point, understanding AI a little bit more from an investment perspective, but also a use case perspective and how we got here. And in the next episode, taking that sort of base knowledge that you have to form and then spinning it forward into what are the investment opportunities here? What are the new investment areas that have come up because of AI? How has it changed some of our thinking about our current investments because AI is supposed to make them better or different or introduce new competition where some investments might not be as lucrative as they were before? So you can see how introducing a topic like AI introduces a number of things that we need to think about and conceptualize in terms of investing. But like I say, this is going to be a little bit of background that leads into the next episode. The next episode is going to be about the AI supply chain and where we want to invest in AI. This is going to be about what do we have now in this AI and what's different from before, how and why are we at this point. I don't think I'm going to talk about stock specifics in this episode, but if I do, just remember that this podcast is for educational and informational purposes. You should consult a financial advisor if you're using any of this information to invest on your own behalf. And as always, if I do mention a stock, I might hold it in a professional or a personal capacity. So just bear that in mind. Now, I've got some sort of talking points on AI. I'm going to sort of run through the sub points just now. We're going to tackle each of them. So firstly, is AI a new invention? Is this something that is a real breakthrough versus, say, 2 years ago when AI wasn't as commonplace as it is now? Then why now? And the how? I mean, what led to 2022 and the launch of ChatGPT being almost a seminal move in AI? Why now instead of 10 years ago or 10 years from now? And I think that's an important question. And then we're going to discuss the sort of three levels of AI. So the AI basics, the building blocks of AI, as it were. That's going to lead into AGI versus narrow AI, and I'll debunk and talk about some of those terms and concepts. And then finally, the economic impact of AI that sort of links us to the investment side. And then finally, talk about some of the investment opportunities, which will segue into the next episode where we talk about the AI supply chain and where we could invest in this AI supply chain if we do think it's a lucrative idea. So without any further ado, I want to discuss the first point. Is AI a new invention? So with the launch of ChatGPT in sort of late 2022, is this AI revolution brand new, or has this been something that's been building in the past? So I sort of dug around, tried to find the first instance of the term AI, and it came to me from someone called John McCarthy, who is actually called the father of AI. If you do look him up online, the term was coined in 1956, so this is a long time ago. McCarthy was a computer scientist, which is very different to a computer scientist now, but he was a computer scientist back then, and he used to host these sort of salons and debates where he would discuss new topics in computer science. And that's where he sort of coined the term artificial intelligence. Crucially, and we're going to get through some terminology now, which you're going to need for the future, is AI never passed the Turing test in those early days when we were talking about it, when they were trying to build early versions of AI. What's the Turing test? Well, Alan Turing is sort of one of the founders of computing. You should go look him up if you want to learn a bit about the history of computing. And he created this test where artificial intelligence could be called artificial intelligence if when a human was interacting with it, they couldn't tell whether they were talking to a human or a computer. So if you're interacting with ChatGPT, if you as a human being can figure out that this is a computer, which you can if you have a couple of interactions with ChatGPT, that was an artificial intelligence. Whereas if you had a conversation with some sort of artificial intelligence and you couldn't tell, you thought you were talking to a human via chat, via telephone, whatever it may be, that was true and proper artificial intelligence. And clearly in 1956, they didn't have anything like that. So John McCarthy coined the idea, but realized very quickly we didn't have the computing power to have artificial intelligence. He sort of listed this equation for what we would need, and it's linked to sort of the World War II project around the atom bomb. He said that we needed to have a successful AI project. You need the kind of investment that had 1.7 Einsteins, so Albert Einsteins, 2 Clerk Maxwells, 5 Faradays, and the funding of 0.3 Manhattan Project. So that's the actual project of the atom bomb. Talking about investment in computing needed to happen for us to get artificial intelligence. So that was 1956. We're now in 2023. Have we had that sort of investment and breakthrough to sort of have AI be successful? Is that why we are where we are? Which leads me to my second point of why now for AI? Why this AI revolution now in 2023? And I guess the how. Crucially, computing power has developed more and more over the years. We all know this, right? We often talk about the computing power in a modern day iPhone is what we used to have in supercomputers back in the day. I'll get a little bit more into terminology about computing when we talk about supply chain next time. It's crucial for that. But effectively, we have something called a CPU, a central processing unit, that does a number of calculations that allows any of our gadgets to work. So if we want to look up directions on Google Map, and when we're saying we're going from our point A to point B, the CPU, the central processing unit, is crucial in computing how we get from point A to point B. It's one of the tasks we're going to give a computer to do. So the CPU is almost the brain of the computer, using all the other tools to do certain tasks. Now, the crucial part about a CPU is that it's built with transistors and integrated circuits. And that's actual physical electrical components that are sort of stitched into a computer or the CPU itself. And I realized that in the 1950s, when John McCarthy was proposing AI, we were sort of doing this in a very foundational way. Humans were doing it, very large-scale machines were doing it. We could only put so many transistors onto a CPU of a certain size. That's why to have a supercomputer back in the day, it sort of filled an entire room. As the years have gone on, we have developed technology that allows us to put more circuits, integrated circuits, onto smaller and smaller pieces of CPU wafers is what they're called, and we'll get into that next episode. The idea is the more and more integrated circuits we can put on a smaller and smaller profile, the faster and faster our computers become, and the less space we need for vast computing power. So previously, the amount of integrated circuits that could fit in a room now has become a small square surface, which is amazing. That's why a supercomputer back in the day that fit in a room can now fit in an iPhone, because the same amount of transistors that we needed for a room can now fit in a very, very small square surface. That is Moore's law. Moore is one of the founders of Intel, so a company that makes CPUs and has done so for a long time now. He proposed that our ability to put transistors onto a chip would sort of double every 2 years. There'd be this exponential growth in our ability to put more transistors onto a smaller and smaller platform. And that means, in layman's terms, our computing power would just develop faster and faster every 2 years and almost exponentially. So when McCarthy said in 1956 we would have artificial intelligence, Moore's law sort of made that a rule that because we were developing so quickly, because we could put more and more transistors onto CPUs, make our CPUs faster, make them smaller, we were almost bound to have artificial intelligence. It was just a matter of when. When did we cross that bridge where we had enough integrated circuits on a small enough platform that we could actually power something like artificial intelligence? And I guess arguably that time is now. In sort of 2022, 2023. In the next episode, I'm going to talk about GPUs and RAM and how those sort of work together with CPUs on a motherboard to allow phones to work and computers to work and all sorts of things. But for now, you just need to understand that the smaller and smaller a CPU can get with more and more transistors or integrated circuits, the more computing power we have and the more we can then do. And we'll come to it in a little bit just now, but artificial intelligence, machine learning requires a lot of computational power. So it literally could not happen in the 50s. It can happen now because we can have such vast computing power in such a small space. And that is crucial. The other thing is, if you sort of work through the language around something like ChatGPT, it's often called a large language model. And this is the sort of leading to the when part of my question. Quite frankly, we've had large language models for a while now. There's a Google I/O presentation that I'll link in the show notes here in the podcast or on YouTube, where Sundar Pichai, the CEO of Google, uses AI to do a couple of tasks. One of them is book a table at an Asian restaurant. He books a hairdressing appointment, and he does one other thing, which I can't remember. Watch the video. It is a much more advanced version of ChatGPT, where he uses his natural spoken language to interact with a form of artificial intelligence. That form of artificial intelligence takes his request and actually contacts a human over the phone and makes a booking or makes an appointment. Arguably, it passes the Turing test because the people on the other end who are real people don't realize they're talking to a computer. But I guess if the conversation went on, they might have. So probably not a passing of the Turing tests in its sort of totality. But I sit back and go, that presentation came out 5 years ago. So we had some kind of large language model inside Google, at least, many years ago. So in terms of the when, it's probably been happening over the last 10 years. We just had ChatGPT sort of put it out there for public consumption earlier than everyone else. And you can see evidence of that because the likes of Bard from Google came out very quickly, even though Google weren't really talking about it. We've seen examples from the likes of Facebook, and every company you sort of interact with now has some sort of AI way of interacting with them. So this AI arms race has been happening for some time now as computing power has increased. But for the first time, they're actually making their way to us, like normal consumers. So in terms of the when, I think it's already been happening, and we're just seeing sort of public versions of them now. In terms of the how, it's all based on the fact that we can compute way faster than we could in the past. Okay, so that takes me to sort of AI basics and terminology especially, because I feel like people get this wrong a lot. There's going to come a point just now where I take away the term artificial intelligence because it's a little bit of a misnomer. We started, and there's 3 levels here. They're all linked to each other. The first is algorithms. And an algorithm, I have the definition in front of me. I'm going to read it out for you. An algorithm is a process or set of rules to be followed in calculations or other problem-solving operations. So it's a very simple process. It is X plus Y equals Z, and that happens the same consistently all the time. Algorithms work all over different industries. I'm sure you use some sort of algorithm yourself. I definitely do, because I have a number of tasks that are very repetitive. It's a very simple process that needs to be followed. There's no sort of thinking or changing that needs to happen. Something goes in, it gets manipulated, something pops out. And I know that process needs to repeat itself. Therefore, I set an algorithm to achieve that task, right? For example, say I have the earnings for a company, and I know that there's certain adjustments that need to be made to the earnings based on the fact that the accounting principles get you to a level of earnings, but there's certain changes that needed to be made so that I can use earnings in a different way. I'll get a computer, typically something like Excel, to take the earnings number, pop it in, make the changes that I need to, spit out a different earnings number at the end. That's an algorithm. No intervention needed in that, no thinking needed in that. The problem is exactly the same every single time. So I'm looking to your own life. You probably have algorithms for a number of different things that you work on every day. Different industries probably do the same thing. After algorithms, we started to get this thing called machine learning. Machine learning was this idea that we have an algorithm, but the algorithm should be able to adjust itself for different scenarios. If we take that earnings example, for instance, say the earnings for most companies can work in that algorithm and be just fine. But say there's a certain sector like financials companies that needs a slightly different treatment for accounting. A machine learning program would start to realize or learn from itself that the algorithm is not fitted correctly for financials companies. So it starts to adjust itself at different layers to make itself better. Say an algorithm did something in the medical field. It set out a certain set of tasks lists for a certain disease profile. And a machine learning program could learn that in certain circumstances, these things don't work and it needs to adjust, or given new information, the algorithm could be adjusted to make itself better. There's a GIF or a GIF that explains this really nicely. It's a game where there's a little motorbike that sort of is running through an obstacle course. It's one of those games where you're just moving forward and obstacles come towards you. And you're supposed to avoid the obstacles and avoid the wall. It's a nice GIF because next to it kind of explains how machine learning works. Machine learning isn't that complicated, in fact. You just want to sort of explain to the computer what is success and then reward it for success as it gets better and better. How does it get better and better? Machine learning works often with trial and error, just trying to do the same thing over and over again, many, many times till the computer gets better. If the GIF is on the screen somewhere, you'll see what I mean. But if it isn't, just look in the show notes again. I'll put a link up to it. So effectively, when the computer starts to learn the game, all it knows is that it can go left and right. That is the only two directions it has. When it starts to play the game, obviously it doesn't know anything. So it either just goes left all the time or right all the time. But it'll start to get points for how long it stays in the game. And as it starts to get points as it plays the game. Now, as it goes left and as it goes right, obstacles are going to appear. And effectively, as the game continues and as the computer avoids certain obstacles, you'll see the points tally start to go up. Now, the computer knows that, and the algorithm knows that it wants to achieve a high point score. So it starts to program itself to avoid those obstacles, to go left as well as go right. And that way, after playing the game millions and millions of times, it starts to realize I can go a little bit left, I can go a little bit right, I should avoid the blocks. The algorithm becomes machine learning because it starts to adjust itself to learn this game. Chess is kind of the same thing. When we taught machines to learn chess, we taught it the rules of chess, the constraints of chess, and then just let it play on its own. And the computer would do very stupid things initially, move only the pawn, for example. But after playing millions and millions of times, it starts to learn. The thing about machine learning that us as humans don't conceptually understand is that machine learning happens exponentially. A computer over a 24-hour-a-day cycle can do the same thing over and over again and eventually start to learn. And it might take millions of attempts to get to even the first stage of success. But because computing power has come to a point where we can let computers just continue to crunch and crunch and crunch numbers and continue to try and try and try in a very effective way, we can have quite good machine learning. That leads us to something called deep learning and neural networks. And this is where artificial intelligence is kind of born and is crucial in the context of what we talked about earlier, because this sort of deep learning requires so much computational power that it couldn't really exist years ago in the 1950s when John McCarthy proposed artificial intelligence. To allow computers to compute vast arrays of data across multiple lines and do that almost to infinity in terms of time and number of attempts, that's where you get a computer to really sort of look across different things. Now, something like ChatGPT works as a great example in this case, because ChatGPT is a large language model. What that means is developers sort of give ChatGPT language to learn. It wasn't supposed to be an intelligent being. It was just supposed to understand language more than anything else. It was just supposed to be able to put one word after the next word to make a reasonable sentence. So if you said, hello, ChatGPT, you got a reasonable sentence back like, hello, user, instead of just garbled letters or garbled words. It was just supposed to formulate sentences. How are they going to teach it to formulate sentences? Give it examples of sentences. How do you do that? Well, this is not known for a fact, but it seems to be that ChatGPT was allowed to sort of rove the internet, go through books and patent and sort of academic papers and just general articles, go through social media posts, go through any form of language that is available on the internet to try and learn, and then start to try and formulate sentences. And you can imagine that initially the sentences were quite garbled, they didn't make any sense. But as it sort of went through more and more of human history that exists on the internet, it starts to formulate better and better sentences because the computer is slowly piecing together what we want. It is learning, but not just machine learning, it is deep learning. Now, this is not an algorithm because the algorithm itself is changing all the time, which is machine learning, but it becomes deep learning when it expands quite dramatically across millions and millions of data points. It's just, we as humans can't conceptualize this, but it's sort of feeding and taking in as much as it can. And quite frankly, that's why large language models can exist today, because they can learn over such a vast degree. So the inventors of something like ChatGPT expected to come back with a large language model that could just sort of talk and make sentences. But given how exponential the learning was, we actually came back with a tool that learned way more than that. It actually seemed to have learned at least, how to respond on different subjects and different pieces of academia. And you could ask it a wide range of questions and get back actually very thoughtful answers. That is the power of deep learning and the computational power that we have today. Now that's ChatGPT, but think about other things. If you use Google Maps, Apple Maps, whatever it may be, that's a form of deep learning, to be able to understand the road network, to understand traffic data, to understand different modes of transportation and transit, and be able to give that back to you in the most efficient way when you ask it where you want to go. That you could call an algorithm, but it's an algorithm that's got better and better because of machine learning and because of deep learning. So you have to sort of structure in your mind what level of computing power you're working with. I would argue most of us could actually create an algorithm quite easily. I think there will come a point very soon where we'll be able to develop machine learning tools where our algorithms get better on their own. And it definitely exists in the world. And we have now seen very good examples of very good deep learning. Now, if we have deep learning, I want to differentiate between AGI, artificial generative intelligence, versus narrow AI. Now, I will put forward that something like ChatGPT or Bard is actually narrow AI. And I've been saying artificial intelligence for a long time, but I'm going to stop doing that now. And I'm going to refer to them as narrow AI. And I'm going to introduce a new term called AGI, artificial generative intelligence, which I'm going to call true and proper AI. Now, I believe that we don't have true and proper AI. I believe that things like ChatGPT are very, very interesting. They're very, very compelling, but they do not pass the Turing test. And I think that is crucial. The second point, sort of related to that, is that current forms of ChatGPT they don't show human creativeness. Yes, I've seen people create poems and stories on things like ChatGPT. It's very impressive. But it's using its learned history of the internet to create that poem, to create that story. It isn't showing new human inventiveness. The idea is, can you get a new Spielberg, can you get a new script from a Spielberg that doesn't exist out of ChatGPT? You can't, because it is using everything that we have before. Whereas when Steven Spielberg or Shakespeare or a new poet put forth brand new ideas and thoughts, it was truly brand new. Like a Van Gogh painting, for example, is very different from everything that existed before it. ChatGPT can't create new things. It can sort of rehash what we have already and give us something new. And that's what separates humans from computers. It always has. This current form of artificial intelligence, unfortunately, can't cross that divide. It can't create something truly new, even though it is impressive. Whereas AGI, generative intelligence, can. The generative means that it can create something almost by itself, mimicking human-like the human-like experience. Now, science fiction has always given us examples of what the future is going to look like. And there are examples of AGI in movies and popular cinema and popular culture. If you take Jarvis from the Iron Man movie, for sort of our Marvel fans, our millennial fans, I'll try and link a Jarvis YouTube link, but otherwise Google Jarvis from the Avengers and you'll see what I'm talking about. That was proper artificial intelligence. Tony Stark, Iron Man, created true and proper artificial intelligence, and he could interact with it. It passed the Turing test. If that's not from your generation, then Computer from Star Trek, the supercomputer, is also an example of sci-fi AI. And then for some of you from the 80s, if you're listening to this, Kit from Knight Rider, the car that interacted with I can't remember his name, from Baywatch, Hasselhoff. That was also a form of AI. It could pass the Turing test. It had creative thought. It could think out the box, think like a human. Those are all forms of AGI. Now, unfortunately, we don't have AGI from any of the tools we have right now because they can't pass the Turing test. But what I would say is that this form of narrow AI that we have today gives us the perfect sort of example and evidence of the fact that we are moving towards AGI. We will get there at some point. How? Well, that sort of development of computing power, that hasn't stopped, right? That continues to get better and better as the years go by. So we are moving towards that AGI world. It's just a matter of how long before we get there. I think it's amazing what they've been able to do with large language models. So I think that timeline for most people has actually come forward now that we understand how quickly we've been able to develop with deep learning. So we have narrow AI. We're sort of on the path, on the road to AGI, which brings me to the economic impact. So we've done all the sort of deep thinking and the deep understanding of this, and we're now getting into the sort of investment case. If we have proper AI, and even now with narrow AI, what's the sort of result on our economy and society, and how can we invest based on that? Well, economically speaking, we as people will get more productive. And if we can get more productive, then we will be able to grow faster, do things better, and therefore there'll be more output. Output in economic sense is GDP, gross domestic product. So we'll be able to grow fast and have higher economic growth because the same number of humans will be able to do way more. We've seen this in different revolutions in the past, like the Industrial Revolution, where the invention of just entry-level machines, conveyor belts, that sort of thing, really changed human productivity and allowed us to reach a completely different level of human endeavor. And that led to this revolution that we're in now. Artificial intelligence, in theory, could take us to an even different revolution, which leads to way more prosperous society. So in theory, artificial intelligence is amazing. Now, there's one point that keeps coming up with artificial intelligence as sort of the negative side of artificial intelligence, and that is higher unemployment. If we have true and proper AI, then many people could actually lose their jobs because we don't need them anymore because AI sort of takes over. Now, the one obvious rebuttal to that argument is that in previous revolutions, people didn't lose their jobs en masse, their jobs just changed. If you watch the comedy Marvelous Mrs. Maisel, or if you just Google it, you'll see examples of telephone operators. So you called, say, a business, and you wanted to speak to person X. You would reach an operator first, the operator would speak to you, figure out who you wanted to speak to. They would then sort of speak to that person and then route your call on the switchboard looking thing. That obviously stopped existing when we could dial direct extension numbers and dial direct phone numbers. But those operators they did lose that job, but other jobs started to become available immediately afterwards. When we started creating computers, we needed things like typewriters. So switchboard operators moved into a different role when things like the manufacturing process for cars became more mechanized. We needed less people to do metal work and more people to sort of make sure the machines did their jobs correctly. We needed quality assurance people, etc. Job roles are always changing. And even without AI, we have had more productivity because we've had more computing power, which means that people are already doing more with less. In my sort of asset management example, my team is sort of 5-6 people, and we cover 1,400 stocks. 20 years ago, completely unheard of. Today, with a Bloomberg terminal, with Microsoft Excel, some reasonable basic algorithms, we can cover a lot of ground with just 5 or 6 people. So the argument that AI is going to sort of take over people's jobs, it's not AI. It's already happening. It happens all the time. Job roles are consistently changing around us, and society adjusts for that. But I do want to talk about this dystopian future where AI does take over a number of jobs and where a lot of people might be unemployed. Well, society will kind of have to change for that, And this is the sort of artificial generative intelligence, or true and proper AI, is really the future and the next level of the human race. And there we might have to discuss what our society and culture looks like. So I just want to put out a weird concept, but it's something that's been going around now, and it appears in sci-fi a lot. The idea of universal basic income, where if we do have true and proper AI that takes away a lot of employment and people don't have to work anymore, then a large proportion of society could just be paid a stipend to exist, to live, called universal basic income. And there's another part of society that has to work to sort of help the machines or create new machines. And those people will earn a salary above universal basic income. If you think about something like The Matrix, which gets even more dystopian, we're all sort of plugged in and we're just electricity sources for the machines. It can get very, very sort of dystopian in sci-fi. So it's all sort of in play when we think about something like artificial intelligence. But for now, with narrow AI, none of that sort of is on the table at the very least. And we can get more dystopian without thinking. And I think it's a good thought exercise. We always need to think about the future. But for now, I'm not too concerned with those sorts of things. The other thing is we have to consider whether this is just not a big deal. I mean, I think it was 10 years ago, but maybe it was less. The 3D printer was supposed to change manufacturing around the world. We were going to bring jobs back from the East because the 3D printer could sort of make stuff for us in our homes. That just hasn't been the case. Okay, so we do sometimes get fads that are sort of proposed as the next generation of human endeavor and the next revolution, but then they aren't, because 3D printing was supposed to be the next revolution in manufacturing. It clearly wasn't. Now, am I saying that this version of AI is a fad? No. It sort of could go either way, but I think with the vast amount of computing power, I think we do go to the next level of AI. So I do think there is some sort of revolution in play. I just don't think we're there yet. We're sort of on the path to it. Now, in terms of investment opportunities, and this is going to lead into the next episode, I really want to talk about the supply chain, how we get from one sort of part of AI to the actual companies that are using AI. What are the components inside and which companies are benefiting from that? So that's the next episode. We want to sort of delve into, now that we understand this AI thing, which companies are sort of fueling this AI boom? How could we get involved as investors? What do these companies actually do? Do they make CPUs? Are they involved in different parts of the thing? How does it all sort of fit together from an investment perspective? So we will discuss that next time. Hopefully, this episode has given you some background on AI, some thinking that's slightly different on AI that you've seen in everywhere else. More importantly, from an investment perspective, I hope it's given you some context on the deeper level thinking that needs to go into you and investments. So if you want to invest in artificial intelligence, you have to sort of become a pseudo expert on the topic. You have to sort of understand the topic a little bit better. And while this conversation was on AI, an analyst and a portfolio manager like myself needs to become well versed on healthcare, on industrial companies, on mining companies, on technology companies, banks, asset management. You have to become a pseudo expert on a number of things. And while that sounds intimidating, it's the thing that drew me to this career. So if that sort of thing excites you, the idea that you come into the office every day and learn something new about a different industry and try to find the investment value in it, then that's where a career in asset management and investments really makes sense. And this is what this podcast is about at the end of the day, to sort of delve into investments, but also give you some context on what this industry is about. Okay, I'm going to stop there. I hope you enjoyed this episode. The next episode is going to be on AI supply chain. If you're watching this on YouTube, comment, send us a question, like the video and subscribe. That would be great. If you're listening to this on a podcast channel, if you have happened upon it, we would love it if you subscribed and rated us if you can. You can reach out to us on social media, which is Instagram, YouTube itself, TikTok even now. We appreciate you listening. If you've gotten this far, I really appreciate you listening and or watching. Thank you. All the best. Take care. I'll see you in the next episode.